Hello, boys and girls in distance learning land. Little chemistry lesson today. We're going to go over real quick with a bunch of real quick videos about 80, 81, 82, and 83 about concentration of some different substances and how we find it, what we think about when we go through it, and basically the calculations. So for lesson 80, we were looking at a little experiment that I would have had done for you on the front table. You would have come in, could have checked it out. But it dealt with some gummy bears. If you look on page 408, basically the gummy bears are all set up for you. It shows you, tells you what you're going to see. So you might look that over real quick to kind of get a feel for what is going on. But basically, the question was, well, what goes on if I take a gummy bear and I put it in just pure water, a little bit of sugar water, a medium amount of sugar in water, a lot of sugar in water, and then straight corn syrup. Corn syrup is basically sugar that has maxed out its capacity in water. It's called a saturated solution. Hopefully, you saw that in the notes. But basically, the idea here is there's a lot of different ways to look at concentration. We can look at grams per liter. We can look at parts per million, parts per thousand, parts per billion for some substances that have real low amounts before they become toxic. Like when you start thinking about mercury or lead in water, the accepted value is parts per billion. I mean, and it's not very many. It's like maybe 1 part per billion. Once you get over that, you start getting sick if you start drinking the water. So, anyway, the big way to look at it in chemistry is through something we call molarity. And that is abbreviated with a capital M. And molarity is just a way of looking at concentration in terms of how many moles do we have in 1 liter of solution. And we might have just a little bit of solution, so maybe it's only 10 milliliters or something like that, but we can still calculate its molarity even though we don't have a full liter. So what I want to do is just take a quick look at a couple of problems. One of them I just made up real quick. The second one was the check-in at the end of the chapter. After we go through these, I'll pause, swap around for lesson 81, and then we'll go through 82 and 83 after that. So the first question I have here is, what is the concentration of 18 grams of glucose in 250 milliliters of solution? And so again, what we look at is molarity. This capital M is equal to the number of moles per liter. And unfortunately, given to us in both of these problems, they didn't give us mole. Boo. Oh man, I have to calculate the number of moles. Well, chapter 14 taught you how to do that. So basically, what we have to look at glucose, it's C6H12O6. So we've got 6 times 12, which is 72. We've got 1 times 12 for the hydrogen, and that is 12. And then we've got 6 times 16 for our oxygen. Again, oxygen being 16 times 6 is 96. If we take all of those guys and add them up, we get 180 grams per mole. Real quick calculation then, right over here, 18 grams divided by 180 grams per mole is 1/10 of a mole, or 0.1 mole. So I know that now, 0.1 mole. Now, very common way to write these questions is not with liters, but with milliliters. So what we have here is 250 milliliters. Most common mistake, you got to take that 250, you're going to slam it in here for the liters. Doesn't work. You got to change that milliliters to liters. So what we have to remember is anytime we have milliliters, we have to divide by 1,000 to find the number of liters. So if I take 250, divide it by 1,000 milliliters per liter, I get 0.25 liters. And so take that 0.25 liters, plug it in here now, 0.25 liters, and zero point 0.1 divided by 0.25 happens to be 0.4. Now I have moles per liter, so I would call that 0.4 molar solution. And that tells me the concentration. So that's the first one. Second one, you're checking what's the concentration of 10 grams of salt in 0.5 liters of solution. So this one was nice. It gave us the liters. So I already know molarity, again, is moles per liter. I know 0.5 goes in there. But again, I have this 10 grams that I got to deal with. Salt, again, is NaCl. Sodium is 23. Chlorine, 35.45. So if I add those guys together, I get 58.45 grams per mole. And then if I take 10 and divide it by 10 comes from here, 10 grams and divide by 58.45 grams per mole, I end up with, I believe it was 0.17 moles. So yes, I checked my answer. It is 0.17 mole. So 0.17 mole divided by 0.5 liters would give me 0.34 moles per liter, or 0.34 molar concentration in my solution. So there's 80. Take a quick pause. We'll get set up for 80. All right, so back for lesson 81 here. What we've got going on in lesson 81 is you guys are trying to take a molecular view at what's going on with these different concentrations of solutions. So the idea here is if I have a particular concentration, let's say I have 1 mole and half of a mole concentration, what happens here? Well, the idea is if that occurs and I take a small chunk out, this small chunk is still a 1 molar concentration. If I look at the whole thing, 1 molar versus a half molar, there's just half as many particles in the half molar solution as there are in the 1 molar solution. So the next question then came from the chem catalyst.